Let's make up some data. We're going to do some data simulations. Data simulations can help us understand the relationship between particular characteristics of data and how they look, the visualizations. We're going to use these simulations to help us train our visual reasoning skills. Because if we can create data that we know has certain characteristics, we can learn to recognize how that looks, what that pattern is. And then when we come across that pattern in the wild, when we're exploring other data, we'll be able to recognize it and we'll be able to understand what the underlying characteristics must be. We're going to use Excel to make up this data. So let's start by making up what would it look like if we rolled a dice. So if you think of a normal six-sided die, what's the distribution of outcomes? Well, what are the possible outcomes? There's going to always be a number between 1 and 6, right? If it's a fair die, if you haven't loaded it, there should be an equal chance of it landing on 1 or 2 or 3 or 4 or 5 or 6. Let's have Excel pretend that it's rolling a dice. I'm going to come and add a new worksheet, and let me title this column Roll 1. So this is the first roll of our die. We want Excel to put in a random number between 1 and 6. We've learned how to do a random number between 0 and 1, but Excel can also do a random between. So I'm going to insert a function. Actually, my formula builder is still open, but I'm going to insert a function. And as I type rand, I can see that there's rand between. Returns a random number between the numbers you specify. Let's insert that function. So the minimum is going to be 1. The maximum is going to be 6. Random between 1 and 6. So Excel chose the number 4. Let's fill down to have Excel roll that 30 times. So I'm going to come all the way down to 30. Let's repeat that. Let's have Excel roll that die 30 times again. So I'm going to highlight that. I'm going to fill to the right. Let's see, 2, 3, 4. Let's have 4 sets. So we've got roll 1, 2, 3, and 4. Do you see how Excel just filled that in? It knows how to count. And then each one of these is a rand between 1 and 6. Let's take a look at what this looks like. We're going to highlight it and copy it, put it on our clipboard with Control C. I'm going to jump to see it. I'm going to come down to the bottom left and choose to add a data set. Control V to paste. Roll 1, roll 2, roll 3, roll 4. Don't worry about them not lining up perfectly. It's really just looking for the commas or the spaces in between them. Let me give this a title. Let's see, dice rolls 1 die. The first column is not a label, the first column is data. I want to load that from the form. I'm going to click OK to say that, yes, I understand that it's only going to be active while this browser session is open, and that if I close this browser session, it will no longer be loaded. When I come down to the bottom left, I can see my data set has been added. Roll 1, roll 2, roll 3, roll 4. Let's take a look at what they look like. What do you think they look like? What do you think each of these distributions is going to look like? I'm going to grab roll 1 and drop it into the empty graph and take a look at it. I'm going to come up to these hot buttons and choose New Graph. Do you see how I've now got 2 graphs? And let me grab another of those rolls and drop it into the empty graph. Roughly what shape are these distributions? Let's make the histograms and see. So to make the histograms, I'm going to click on the wrench. I'm going to want to do an advanced mode. Let's click on that gray advanced mode. Now the wrench has the options to make a histogram. So a fixed interval. See, it has a bit of a glitch. I've let them know they're going to work on it. For right now, we can work around it, but let's see what the glitch is. So what is the glitch in this where I have said, make me a histogram with a fixed width of 1. There are, let's see, 29. Oops, did I not go all the way to 30? There are 29 observations in my sample, but let's 8, 12, plus 12, plus 11, plus 9. That's way more than 29. Each observation is being counted twice. So in a histogram, if it's going from 1 to 2, we write it as from 1 to 2. But what we read it as is from 1 up to, but not including 2. And that's what See It needs to update. But we can trick it for right now by just saying start at 0.5 and have an equal interval of 1, fixed interval width of 1. And so we can see now that we've got an accurate histogram. And I can click Apply to All. Explore your other roles. We can add roles to these graphs. So I've now got roll 1 and roll 3 together. Does that make sense? Were they the same? Yeah, they were the same. They were 2 samples of rolling a 6-sided die. If I put them all in together, we should be seeing a pretty flat pattern. Is that what you expected to see? That the distribution would be quite uniform, quite even, that you should roll a 1 just as often as you roll a 2, just as often as you roll a 3. So if we come across a uniform distribution or a sort of rectangular distribution, then we know that there's an equal chance of any of the possible outcomes. That's what a uniform distribution means. All right, what if we had 2 die? If we were rolling 2 die together? Let's think about what that distribution would look like. So first off, what are the possible outcomes? Think about it. If you had 2 6-sided dice and you rolled them together, what's the lowest possible roll you can roll? It would be the 2 1s, right? So that would be a 2. And what's the highest possible roll you can roll? The 2 6s, a 12. Let's have Excel do that for us. So here in cell F, I'm going to type 2 dice. I'm going to add roll 1 and roll 2 together. Equals A2 plus B2. Now don't be alarmed if all of our dice roll recalculate, because they will recalculate when we change things. And I can fill that down. So I've added together rolls 1 and 2 to make a 2 dice. What do you think? What's it going to look like? What's that distribution pattern? Let's go and see. I'm going to copy it and add a data set. And paste it. Load that, say OK. I'm going to click and drag and drop that into an empty graph. I'm going to use that same trick of putting it at the 0.5 to make sure that, see, it is only counting each instance once. So show me that histogram. Is that roughly what you have? Did you get a similar histogram with it being higher in the middle, particularly at 7? 7 should be the highest. 7 should be the most frequent. And 2 is only got one observation. I didn't even get any 12s. Next, we're going to explore a distribution that we call a bimodal distribution. Bi means two. Modal comes from the word mode. So a distribution with two modes. The mode is the most common value in the data, and data sets can have one mode or can have multiple modes. Bimodal distributions have two modes. When you come across a bimodal distribution, you might look at it and wonder if it's really two samples from two different populations mixed in together, and if that's why you're seeing those two different modes. Let me show you what I mean by that. So we're going to simulate data that might show the difference between learning this material in a hybrid format and learning it in a traditional lecture format. So I want to generate two normal distributions of hypothetical student scores, and each of those distributions is going to have a different mean and a different standard deviation. So they're going to have a different central tendency and different variability. So I'm going to generate this data by randomly generating test scores. Let's go and have a look. First off, let's see, this was the roll of the dice. So I'm going to double click and label that worksheet dice just so I can remember what it is. I'm going to add a new worksheet. And let's call this one test scores. In cell A1, I'm going to type the label class type. I'm going to hit the tab key. In B1, this is where we're going to make up the exam 1 scores. In C1, we'll make up exam 2 scores. And then in D1, in column D, we'll calculate the grade. So let me type the column label grade. I'm going to hit an enter. That's going to take me back to the beginning of that block. So the first group of students are going to be taking the format as a hybrid class. And I want to have 30 students taking it as hybrid. So I'm scrolling from A2 down to A31. The next 30 students are going to be taking it as a traditional class. So let me type the word traditional. And again, let me scroll down. So from 32 to 61, I'm double checking down here that I've got a count of 30 so that I actually have 30 people in each of my groups. So I've got one variable, class type, how do they take the class, measured categorically with 2 levels. They're either taking it through the hybrid version or they're taking it in a traditional lecture version. I'm not going to make up their exam scores. We're going to make the hybrid version do better. So we want a random number. So I'm going to insert a function and I'm going to choose random between. And for this one, for the bottom, I'm going to say the lowest score was a 90 and the top score was 100. That's how well the students taking it in hybrid are going to do on the exam. So let me set all of the students who took the hybrid version to have a score somewhere between 90 and 100 on that first exam. They're going to do just as well on the second exam. That whole block is highlighted. I'm going to come down to fill and fill right and fill in the second exam as well. So each student has 2 scores between 90 and 100. Now let's fill in how well the students in the traditional format will do. So we again want to insert a function, random between. let's say these students don't do quite as well. So 70 is going to be the lowest score and 95 is going to be the highest score. So I've set their average is going to be lower, right? Because they're going to be randomly assigned between 70 and 95. Are they going to be more spread out or are they going to be less spread out? Right, they're going to be more spread out because there's more of a spread, that some people did as badly as 70 and some people did as well as 95, whereas the group in the hybrid was very tightly clustered between 90 and 100. Let me fill down and create those exam scores for my students taking it under the traditional method. And let me fill across for their second exam as well. Now we need to calculate their final grade. Their final grade is going to be the average of exam 1 and exam 2. And I'm going to fill that down for all 60 students. There are my class averages. Let's take a look at them. I'm going to highlight all of the data. Control C to copy. And I'm going to jump to see it. I'm going to add a new data set. And Control V to paste. Let's call this one class grades. We don't have a label. We're going to load that worksheet from the form. Let's see what we ended up with. We've got grade. We're going to dump it over here. And there is our sample, or there's our population. Here are our 60 students. They're all the same color because we haven't told SEEIT that there are two different groups. Remember, we're pretending that we don't know that there are two different groups. We're saying, what if these were just 60 students? If we came across this pattern of data, what would we think was going on? How would we interpret this? Let's take a look at the histogram. I'm going to drop that down to 5. I'm going to drop it even further. Let's drop it down to 2. So here's the histogram that I ended up with. I've got a group clustered here between 80 and 84. And then I've got another group clustered here between 94 and 98. You can see this is quite spread out down here. This is very tightly clustered up here. Is this what you expected given what we have just done where we created one group? This has got to be almost entirely those hybrid students that was very tightly clustered with a very high central tendency. And then another group that was less tightly clustered. So they probably range around here quite a lot and had a much lower central tendency. So if you come across this pattern in the wild, you might look at that and say, if only I knew the predictor variable that would help me understand this, that would allow me to separate this into two meaningful groups. That's exactly what you'd say, isn't it? And that's where we're going next. We're going to start looking at the continuous outcome variable in groups and seeing if we can draw conclusions, make comparisons.